Extraordinary knowledge in the ancient Surya Siddhanta. The Surya Siddhanta itself claims it was first spoken by Surya, the sun god, and he shed with Mayadanava 2 million years ago. He is proficient in mechanistic science. He passed that on through sages, demigods and demons over many years until it reached the earth. The Surya Siddhanta was first written down around 1500 BCE. Varahamihira of the 6th century AD revised the scripture. Bhaskaracarya of the 12th century modified it and added Siddhanti Shriyamani. Then in around 1860, Reverend Ebenezer Burgess translated that work into English. Afterwards, Bimal Bashar Dutta translated the 12th century text into Bengali. He was an expert in Vedic astronomy and astrology, but later changed direction and became Bhaktisiddhanta Sarasvati Thakur, focusing on Krishna Bhakti. Note that in all Vedic scriptures the earth is placed at the centre, but that's just relative motion in space. The value of an ancient yojana sometimes differs. The Bhagavad Purana's value is about 8 miles, but in the Surya Siddhanta it's about 5 miles. So we will be working with that. Now the Surya Siddhanta 159 describes the diameter of the Earth as 1,600 yojanas. That works out at about 8,000 miles. That's very close to the modern estimate, which is 7,928 miles. From that, the Surya Siddhanta explains how you can find the circumference of the Earth. Now, from figures in the Surya Siddhanta about planetary motion seen from Earth, the following information can be drawn. Days taken by the planets to make one full cycle around the Earth. Compare. The Sun cycle, of course, corresponds to a year, 365.26 days for the Surya Siddhanta, exactly the same figure for the modern. The Moon, 27.322 for the Surya Siddhanta, which of course is a month, a very similar figure for the modern. For Mercury, 87.97 for the Surya Siddhanta, modern figure extremely similar there. And for Venus, it is 224.7 days for both modern and the Surya Siddhanta. Mars, 687 days for both. Jupiter, 4,332.3 for Surya Siddhanta, similar figure for the modern, and these similarities goes also for Saturn and Rahu. I'll get more into Rahu, however, soon. Now let's look at the Moon. Chapters 4 to 6 of the Surya Siddhanta present rules for calculating the times of the solar and lunar eclipses. They're based on the same theory of eclipses in modern astronomy, and they're no less accurate. The Surya Siddhanta agrees that solar eclipses are caused by the passage of the Moon in front of the Sun. In fact, there's only one notable difference from the modern view. The solar eclipse of the Surya Siddhanta includes a separate planet, Rahu. Now Rahu is said to be an immortal form of a demon's head. That, however, is not essential to the calculations of the Surya Siddhanta. Rahu is included most probably because Vedic astrologers needed a system that would tell them when this inauspicious planet would be on people's charts. Now let's look at the diameters of the planets. This is a fascinating section. First of all, if we took the modern version of the orbit of the Moon, for example here, 2,160 miles for the Moon's diameter, and nearly about 1.5 million miles distance for its orbit path. According to Surya Siddhanta, of course, is very similar. For example, just a bit larger, and it's just a bit further away for the Surya Siddhanta. Average distance from the Earth for the Surya Siddhanta is 258,000 miles, while for the modern, it's about 238,900 miles. Very similar figures, not much difference. Calculating the diameters of the planets. The Surya Siddhanta 713 reads, the diameters upon the Moon's orbit of Mars, Saturn, Mercury, Jupiter and Venus are reduced to 150 miles, 187.5 miles, 225 miles, 262.5 miles, and 300 miles. That's of course figures converted from yojanas. Now in the 12th chapter of Surya Siddhanta we also look at the orbital distances from the Earth of these respected planets. This is what you get. If you get one point of a triangle from the centre of the Earth, extend two sides of that triangle up to the diameter of the Moon, and put in there the aforementioned figure, you get what we call the reduced diameter of that planet. Extend those lines past that point and go to the orbital circumference of that planet mentioned in chapter 12. And here you actually get the diameter of the planet, a very similar figure to modern estimates, as you'll see. The greater reduced diameter on the Moon's orbit, the greater the orbital distances, will lead, of course, to a greater size of that planet. So let's compare the Surya Siddhanta to the modern. Diameter of Mars, Surya Siddhanta, 3,771.7 miles, the modern 4,191, quite similar. Saturn, 73,882 miles, the modern just slightly less at 72,000 miles. Mercury, Surya Siddhanta, just over 3,000 miles in diameter, modern 3,100 miles. Similar. Now, if the figure for Jupiter is doubled, it fits in very well. Perhaps the Surya Siddhanta was referring to its radius instead of its diameter. This could be down to the poetic nature of the verse, or simply human error. Look, very similar figures there, both over 83,000 miles across. The same radiator into diameter formula also applies to Venus, again a similar figure. Look at all the planets there for a size comparison. One big happy family. Distances of the planets from the Sun. Now, one astronomical unit is called an AU, not astrological as I've written here, and it means the distance between the Earth and the Sun. In modern, that's about 93 million miles. However, the Surya Siddhanta appears to underestimate the size and distance of the Sun. The modern Sun is much larger and further away. However, in the Bhagavad Purana's 5th canto, we find reference to the geocentric Earth-centered orbit of the Sun, ranging anything from just 86 million miles to over 100 million miles away. The average of those two figures for the Sun's orbit is actually just over 93 million miles. The Bhagavad Purana gives a distance of about 120 million miles from the Earth to the Manasatara mountain, but that is not the Earth-Sun distance. Rather, it is a parameter occupied by demigods that supervise the Earth. Now here's the orbit of Venus from an Earth-centered point of view. The average distance from the Earth to Venus would therefore be about here. It is the average distance that is calculated for the following section. Using figures from the Surya Siddhanta, one can calculate the astronomical unit distance between the Sun and each planet in the solar system, up to Saturn. Let's look at that. There is, of course, will be 1 AU between the Sun and the Earth here, but let's make a comparison with the other planets. The Surya Siddhanta, 0.368 for Mercury, modern 0.39, quite similar. Venus for the Surya Siddhanta is 0.725 and the modern is 0.72. For Mars, very similar figures, also an average of 0.53. Surya Siddhanta 5.07 for Jupiter, modern figure is 5.2. And Surya Siddhanta's measurement for the distance of Saturn 9.11 and modern 9.55. A remarkable comparison there. The purpose of this presentation is to show that knowledge of modern style astronomy was known to sages of ancient India who certainly had advanced mathematical capability. Evidently, they also knew things such as the diameters of the planets, which would have required powerful telescopes or even mystical methods. The ancient Vedic civilization was not only spiritually advanced, but it was a lot more scientifically astute than what modern historians realize. Thank you for watching, and please share.